Hello. Today we're going to be doing a quick solar energy problem, and it's pretty simple. So in the problem, it says we're given a photovoltaic cell of an area of 1.8 centimeters. So if we have a cell that's 1.8 centimeters cubed in area, and then it says it receives radiation at a rate of 700 watts per meters squared, right? So what we can do from here is, if it's asking us what electrical power is produced of its efficiency is 18%, we should first calculate how much electric power is produced with 100% efficiency. So in order to find this, we can just use the area, 1 for part A, 1.8 centimeters cubed. And first we have to convert it to meters because this right here is in meters. So there's 100 centimeters in 1 meter, and then again, because it's squared. And from here, we're just going to use this rate of radiation. So for every meter squared, we have 700 watts of power. And this should give us our power output if the efficiency is 100%. So what we're going to get is 1.8 divided by 100 divided by 100 times 700, which equals 0.126 watts of power. So in order to account for the efficiency of 18%, we just have to take 0.18 or 18% and multiply it by 100% of the power, which is 0.126 watts. And this should give us a power of 0.02268 watts. And that's the answer for part A. Now, looking at part B, it says if the voltage across it is 0.74 volts, calculate the current through the cell. So for part B, we're going to be using the equation power equals V times I. And if we know the power is 0.02268, we can use that and plug it in. And then divide it by the voltage in order to calculate the current right here. So the voltage is given, and it's 0.74 volts, and that's equal to I, which makes I equal to 0.0306 amps. So for part C, it says how many cells will be needed for a power output of 50 watts. So we see here that if we have one cell right here, we have this much power. So we can use this as a sort of relationship. And so we're trying to calculate 50 watts total. And we know that each cell has 0.02268 watts, and that's for one cell. So now we're going from watts to cells, and if we do this, we should get 0.02268, and that gives us 2,204, or 5 if we round up, cells to get 50 watts of power. And we use 2,205 because we can't have half a cell or whatnot. So for part D, it says what would be the total area of the cells. So we have 2,205 cells, and we know that each cell has an area of 1.8 centimeters squared as given. So if we do one cell for 1.8 centimeters squared, and then convert it to meters. We are given, so take this number times 1.8 and then divide by 100 twice. We're given 0.397 meters squared. And yeah, that's the problem.